Hi everyone and welcome to my channel. This video I'm covering the topic of trig equations and how to solve them. This is really done in Form 4, Form 5 and it's covered mainly in Add Math. Now I'll start off pretty simple and then I will end up getting into multiple angles. So it should be a pretty interesting video with many worked examples and of course the detailed explanations. So please stay tuned to see what I have in store for you. So as always, when I start my videos, I like to go through a little brief recap of everything that you need to know. If I have my X and Y axes like these, then what I know is that there are 4 quadrants. This is my first, my second, third, and fourth. Now some of you may know this rhyme. It goes all school teachers curse, right? So all represents all 3 trig functions would be positive here. S represents only sine would be positive here. T represents same thing, only tan. And of course, C represents only cos is positive in the 4th quadrant. So simply learning this off could really help you do your questions. Now let me move on to my first example. Number 1, solve 8 sine x equal to 3. Now they told us where x is between 0 and 2 pi. This information tells us that we are working in radians. So the first thing you need to do is make sure your calculator is set to radians. If it were instead this, 0 to 360, then we'll have to make sure that your calculator is in degrees. In this first question, there's only one trig function, which is sine. So this is pretty simple. All I will do is simply send over everything until I have x alone. So I have 8 sine x is equal to 3. I'll send the 8 over first. The 8 is multiplying. I'll get this. And then I'll send the sine. Sine inverse of 3 on 8, and I work this out with the calculator, and this gives me 0.384396774. Now that is actually the value for the first quadrant here. Now since my question started off with being positive, right, it means that I need only positive quadrants. So sine is positive here in the first quadrant and in the second quadrant. Now if I need to get the first quadrant answer, it will just be simply this same value here, 0.3844 I should go for 4 decimal places, and for the second quadrant it will end up being pi, take away this entire value. So working this out now, I will end up getting x is equal to 0.3844 radians, this little c represents the radians, and also 2.7572 radians, both of them written to 4 decimal places. Example 2. Now I'm asked here to solve 5 cos x plus 2 sin s is equal to 0, again between the same range. Now I have 2 sets of trig functions here, cos and sine. Now this is kind of difficult to work with if I have 2 separate ones. But what I need to do now is analyze this equation to see if I could do something to it in order to get only one function. Now one connection that cos and sine has is tan x. Tan x is sine x on cos x. Right? So if I were to divide throughout by cos x, that is divide this by cos x, this by cos x, and this by cos x, let me see what will happen. I'll end up getting 5 cos x on cos x plus 2 sin x on cos x, and of course 0. This will become 5 alone. This will actually become 2 tan x, and then I simply work this just like the other sum from before. Now I know that I have tan x is equal to negative 5 on 2, but when I'm working out my tan inverse of the value, I tend to ignore that value and put just 5 on 2. This will give me my first quadrant value here. So putting in this gives me this long value here. However, that is only for the first quadrant. And what I need to really find is where tan is negative, because that is what it had asked for before, right? It was a negative 5 on 2. So tan is actually negative here, in the second quadrant and in the fourth quadrant. So for me to get the second quadrant answer, I'll have to take that same value here that I got here, and I'll have to take pi and take it away from pi. So I'll have to do this, and for me to get the fourth quadrant answer, I will have to take 2 pi and take the full value away as well. So simplifying these two answers, I will end up getting 1.9513 radians and 5.0929 radians. So this is my answer for my second question. Example 3 now. 2 sine squared x is equal to 1 plus cos x. Now, what's happening here is I have two functions. However, there is a connection between sine squared x and cos x. I know that sine squared x, plus cos squared x is equal to 1. Another way that could be written is I could say sine squared x is equal to 1 minus cos squared x. So I could substitute that for here. So what I'll end up getting is 2 by 1 minus cos squared x is equal to 1 plus cos x. Now, this line here now tells me that I only have one variable in it, which is cos x. So now, simplifying, I'm bringing this across. This actually looks like a quadratic. It's actually minus 2 cos squared x minus cos x plus 1 is 0. So I really dislike working with negative x squareds and so on like this. So what I'll do, I'll just multiply by negative 1. So I'll end up getting 2 cos squared x positive 2 cos x minus 1. Now then I'll say let y be equal to cos x. So then this line actually becomes 2y squared plus y minus 1 is equal to 0. Factorize, and now I get 2y here, y here. I'll end up getting minus 1 here and plus 1 here. Now equal to 0. Now solving, now I get 2y minus 1 is equal to 0, and also y plus 1 is equal to 0. So converting that back now to cos x, I'll end up getting 2 cos x minus 1 is 0, and cos x plus 1 is 0. Simplifying again, I will get, on this side I'll get cos x is equal to a half, and then x is equal to cos inverse of a half. Now cos inverse of a half will actually give me 1.047, which would be the first quadrant here, where it's positive. So I would want this answer here, and I will also want the answer here for the fourth quadrant, which would be 2 pi minus 1.047, and that works out to be, for this solution, 5.236 radians here and here. Now I'm not done, I still have this piece to do. Now what happened here now was that this was a negative, but when I find the cos inverse, I don't use a negative, I just plug in the 1. Cos inverse of 1 is actually 0. Now you might say 0 is not an answer, but actually I could still continue working. Now it's a negative quadrant. It's a negative answer, sorry. So I have to look at the negative quadrant answers. So that would be in the, sorry about that, just changing my colors. That would actually be, negative quadrants would be the second quadrant and the third quadrant. So for my second quadrant, my answers are actually pi minus 0. And then for my third quadrant, it will be pi plus 0, which both answers would actually just give me pi. So my three answers then, guys, would be 1.047 radians, 5.236 radians, and of course pi radians. So these are my three answers for number 3. Now in this question it says solve 2 cos 2x minus root of 3 is equal to 0. Now because I have this 2x here, this means that this is actually multiple angles, right? So what this means is that whatever value is in front of the x, that is how many revolutions you're going to go. So if there was 2x, like in this case, I would go around once and then I'll go around again. So I may get double the amount of answers as before. If there were if it was 5x instead, again, I will do 5 revolutions. So let me show you how I'd work this. Firstly, I'll just work it like regular. Send over this, send over this. Well, of course, I'll send the root 3 first. So I'll end up getting 2 cos 2x minus root 3 would end up being cos 2x is equal to root 3 divided by 2. Then 2x is equal to cos inverse of this, of course, ends up being this value. Now this is the value for the first quadrant. Now again, we need to get where cos is positive. So that will be in the first quadrant and the fourth quadrant. In the first revolution, now we are dealing with 2x. So it means that we need to do 2 revolutions. So my first revolution will give me 2 answers, the first quadrant and the fourth quadrant, which will actually give me this value here and this value. This is the first quadrant, and the fourth quadrant in the first revolution. Now in my second revolution, I will end up coming back here, which is, you could kind of call it the fifth quadrant, right? So if I'm coming back here now, I would have already made a full revolution. So I now have 2 pi in my pocket. and I need to go into the fifth quadrant. So then this value here now will end up being 2 pi plus this whole value from before. That's for the fifth quadrant. I'm just calling it the fifth quadrant, right? There's really no such thing as a fifth quadrant. The fifth quadrant, when I use that word, I simply mean the second revolution, the first quadrant there. Now, that is this quadrant here, right? In my second revolution. Now, again, cos is positive here. In this quadrant here, in my second revolution now, here will be 2 pi, here will be 3 pi, and then when I come all the way around here, here will end up being 4 pi. So then I will end up getting 4 pi take away all of this. So this fourth value would look like this. Now, I need to work out these four answers here, 1, 2, 3, and 4. And then the last thing I need to do is divide by 2. So let me do that now. So I end up getting 2x is equal to 1, 2, 3, and 4 values. And then simply dividing by dividing by 2, each value by 2, my final answers would end up being x is equal to 263 radians, 2.8786 radians, 3.4046 radians, and 6.0202 radians. Please note though, guys, when you get your answers, like in this particular case when I got my 4 answers, I have to make sure that they fall into my range, which is here. If any value goes outside of this, I would not consider it as an answer. Right, so now let me move on to example 5. So in my fifth example now, I have again a multiple here, but it's now 3/4. 3/4 of x means that I'm only going not through a full revolution, but I'm going 3/4 of a revolution. So I'm starting here, I'm going to this quadrant, and then I'm stopping here. So I'm really catering just for 3 quadrants. Now, if you notice, only some of my trig values are positive in the 3 quadrants. It ignores the 4th quadrant. So say this question was with a cos, then I may have to disregard one of my answers. Okay, so let me continue. So again, simplifying, sending over everything. And this as well, I'll end up getting 3/4 of x is equal to sine inverse of root 2 on 2. That works out to be actually 0.785398163. That is the answer for the first quadrant. Now, do I need the first quadrant? Yes, I do. And I also need the second quadrant answer. So the second quadrant answer will be pi, take away all of this, and that gives me these two values. This and this. Now, is that my final answer? No, guys, it's not. I still have to deal with this 3/4 here. So I have to send this over, which means that I'm going to take these two answers here and multiply by 4 and 3, multiply by 4 and 3, and then my final answers, guys, will end up being this 1.0472 radians, and my second answer will be 3.1416 radians. That's it, everyone. So this, guys, is my sixth and final example. Now again, the same rule applies, you send over everything, right? Now if you look at the layout of this one, there's no multiple in front of here, but there's this value here added. So let me continue. I'll write this out like this and then send over. So I end up getting x minus pi on 2 is equal to tan inverse of the root of 3, which works out to be 1.04719751 in the first quadrant. And then, seeing that I'm dealing with tan, and I want to get where it is positive in the third quadrant, it will be pi plus this value here, and that gives me 4.188790205. Now, you may think that this is your final answer, but no, I still have to deal with this minus pi on 2. So if I send this over here to apply it to this value and this value, I'll have to actually be adding pi on 2 to this value and to this value. So that ends up giving me 2.618 radians and 5.7596 radians. Now, please note, guys, well, firstly, I need to remember this is my range, and these two values still fall within my range. So I would accept both answers. Now, again, please note that all answers done for these 6 questions were done rounded to 4 decimal places, right? Also, I hope that these 6 questions bring you some sort of clarity to this topic, and I hope that you feel at least less intimidated by them and realize that each of them can be done differently using the different principles. So please feel free to like, share, and subscribe. Thanks, guys, for tuning in.